coding project.
Is it okay if we record this, by the way?
Yeah, sure,
Sorry.
of course. And yeah, and then you get a chance to sort of walk through a version of that project on your own, either in Python or R. I wasn't quite sure which programming language you're working with. So let me share my slides, and then we take it from there. Whoa. All right.
Yes, we can see it now.
Perfect. All right. So the topic I want to talk about is sort of at the intersection of a number of my, trying to minimize these. That's fine. At the number of my interests. So originally I'm a psychologist by training, and in recent work I'm working a lot with in recent years I'm working a lot with large language models, applying them in particular to try to address meta-scientific issues. And this topic, this presentation is very much in that direction. So what we're trying to do here is use large language models to address issues of conceptual clarity in psychology, especially concerning the use in the interpretation of the measures that we apply in order to measure all sorts of different dimensions of human behavior, human thinking, etc. And the problem was recently very nicely shown by Malte Elsen, Ruben Aslan, and colleagues. What they did in this analysis is that they looked at the PsycTests database of the American Psychological Association. The American Psychological Association is the largest publisher in psychology, and they started to collect and document all of the different measures and constructs that psychological research has been proposing over the years. When I say measure, I mean anything that sort of can be measured in a number or a label about something psychological, right? And a construct is then the thing that this measure is supposed to measure. And what you see tabulated here or illustrated here is the cumulative number of these measures and constructs. And what you can see is that in 2023, so the numbers today will be higher. In 2023, we had 71,000 different measures that psychologists have proposed, or at least that have been documented within that PsycTest library. Overall, it's probably a much larger number, right? And then we can ask ourselves, do we really need that many different measures of human psychology? Does psychology really live in a 70,000 or 100,000 dimensional space where we can see, reliably measure all of these different dimensions independent of each other, right? And the same with constructs, right? I mean, this analysis identified more than 40,000 constructs. Are there really 40,000 different things that we can measure about human psychology? And maybe they are, but what is probably the case is that there are practical limitations for us to do this, right? And these practical limitations, on the one hand, come with the noisiness of measurement, and on the other hand, come with an academic system that is not rewarding sort of a clear taxonomy of measures and constructs where we would really know what all of these different measures and constructs really are doing. So here's one example that is telling us that there's really something off with all of these different measures and their assignment to constructs. So one of my favorite studies, it's a study by Renato Frey and colleagues conducted in Berlin and in Basel, where they've measured risk-taking tendency using like some 20 different tasks that have been proposed in the literature. Some of them are self-reports, so this is where people rate themselves on a scale from from 1 to 5 or 1 to 7, right? Rating them on, so what all of these trying to measure is really how risk-taking they are. So whether you're a person that is more likely to take risk or a person that is less likely to take risk, which is a super relevant context and a sort of measure in all sorts of different contexts and finance and health, etc. So some of them are self-reports, others are more behavioral in nature. So for instance, people would be asked, would you rather like to play a lottery that has some risk where you may win something or lose something, or alternatively, choose a lottery that is more safe, right? And then the more you choose the risky lotteries, the more risk-taking you're supposed to be. And then finally, they also had some frequency measures that are sort of a little bit more in the domain of the real world, where people report the frequencies of risk-bearing behaviors in the real world. And one thing you can, and what this figure now shows is the correlations between all of these. And one thing you can really see is that all of these correlations, I mean, the numbers may be small, but the colors are indicating it. All of these correlations are really, really low, right? And that's a problem because all of these different measures are being used in the literature to measure risk-taking. And people are writing papers using these measures, studying risk-taking. And if the correlations are also low, that means that all of these different studies are probably studying something different, not the same thing, right? So if they would all be studying the same thing, all be studying this one dimension of risk-taking preference or risk preference, then the correlations would have to be much higher, up to the limit that the reliability of these measures are setting, but they're much, much lower. Interestingly, especially when we look at what is considered the gold standard of measurement, oftentimes it's psychology, but also economics. So in particular, these behavioral tasks, they basically don't correlate at all with one another, right? And this is now telling us that across the literature, at least with respect to risk-taking, but I believe this is, or I'm confident that this is a general pattern, we often don't really know what our measures are actually measuring. Here's another example in the domain of emotion. So this is showing all of the different adjectives that are being used in order to measure different emotions. And here the overlapping circles are indicating that one and the same adjectives are being used to measure different kinds of emotions, right? Which again means that we don't actually know how our different measures, which would in this case be the emotions that maybe people rate themselves on, relate to the different constructs that we want to measure. So I really consider this to be a massive problem in psychology, but by extension, a massive problem of the behavioral and social sciences, that there are too many things out there that are being proposed by researchers that, of course, are being rewarded by the fact that they come up with new things. And that all of these things, we don't really know how they go together, right? We don't usually even know what exactly we mean by a construct. We actually don't have good taxonomies of constructs that would provide, for instance, definitions, right? Not even within the smaller fields of psychology, for instance. The American Psychological Association, for instance, has a dictionary of definitions, but it only covers maybe a couple of % of all of the different constructs. And the definitions aren't very good, right? And then we don't know how all of these different measures that we have actually relate to all of these different constructs. So what I'm doing in my work is really try to produce solutions, not solutions that are necessarily perfect in addressing the individual elements of the project, but are scalable, which is really crucial because the numbers we're dealing with are not numbers that at this point we can really address easily using empirical work. Not everyone can run a study with a couple of thousand participants and dozens of behavioral measures because these studies are really, really expensive. So what I'm trying to produce are scalable solutions based on large language models addressing that problem. And what I've been working on in particular is try to map the measure relationships automatically. So try to identify how two measures of human psychology or behavior or thinking relate to one another, and then also try to find ways to figure out how to then map these measures to the constructs that they're supposed to measure. And I want to give you one example from that tries to do this in the domain of these self-report items. So this is a paper together with Roy Mata, where we sort of pioneered an approach where we can use large language models to automatically relate all sorts of self-report based measures to one another, and then also link those to the constructs based on the construct labels to identify issues in the taxonomic system of self-report items. This would be in particular in the domain of personality psychology, but also automatically produce new solutions that are maybe less afflicted by misassignments of measures to constructs, and maybe also more parsimonious. All right, let me jump in. So the domain we're working with here is the domain of personality psychology. And specifically, we're working with a database that's known as the International Personality Item Pool. It's a database that at the time when we analyzed it had 459 different scales. And a scale is a measure, a scale is a collection of items, so self-report items. So, and then people rate themselves on each of these different items, and then the ratings of these items are averaged together, and that will be a measure. And then each of these scales also has a label that is indicating the construct that the scale is supposed to measure. And what you see here are all of the different construct labels, 459 of those. And what you can see is that, there's a lot of them, but this is really just a small portion of personality psychology. And also you see that there's a lot of overlap. So for instance, there's like 10 different ways of measuring gregariousness, right? 10 different scales, or there's a lot of different ways of measuring orderliness or organization, right? So here we can ask, do they really all measure the same thing, or do some of them maybe actually measure something different? But we also see we have scales to measure friendliness, gregariousness, extroversion, sociability, etc. These are all super, super similar things, right? Is it really true that a scale for gregariousness is really just measuring gregariousness and not measuring friendliness or sociability or whatever, right? Yeah, and we wanted to, figure out how large the problem is of sort of taxonomic messiness of conceptual clutter, and then maybe also figure out a way to fix it. And the way we do this is by using language models, right? So for a few years now, we have these amazing tools that we can use to perform computation of meaning, right? Which is not at all a new idea, it just got a lot better. So this idea of using semantic vectors to compute meaning, right, is something that's rather old already, coming from the cognitive sciences. So for decades, we've been already able to do this, but now we have these tools that are really great at producing representations, not just of words, but of entire sentences. And they're also really easy to use. We can just pluck a pre-trained model from a platform such as Hugging Face, right? And then we just take a sentence that we care about, we feed it through that model, right? Right, the computations within that neural network propagate up to the very end of the neural network, and then we can look inside of the neural network just before the neural network would be producing an output, right? And just record the activations that we see that are being produced for this particular sentence at the very end of the model. And then we can take these activations as a semantic code that we can use to evaluate how the meaning of this sentence compares to other sentences that we might be interested in. And so what we've done in this project is we just took all of these items. So it's about 4,500 items that make up these 459 different scales, as well as all of the different construct labels, and we fed them each individually to a language model, recorded the activations, which then places all of them in a high dimensional space. Specifically, we used a fine-tuned model. I'll tell you more about this in a second. That places them all in a high-dimensional space that allows us to relate all of them to each other, right? And perform evaluations of relatedness. So it's a little bit easier to think of this really as a space, right? I mean, it's also a data matrix, right? Where we then have rows for all of the different elements we care about, items and constructs here, and then columns of all of these abstract dimensions. But we can also think of this really as a space where then all of these different things are located in there, and their relative position to one another is encoding how related they are, right? How do we know this? From all sorts of different tests. I mean, but going back to the research using word embedding models, and now with these sort of text embedding models that we have available today, we know that the relative position of these vectors in the space, which we usually measure by their angle to one another, we know that they map relatively closely human intuitive assessments of relatedness. And also that they're really useful to reconstruct categorizations and all sorts of different things. Not perfectly. So these spaces are not a perfect image of human intuitive assessments, but they're relatively close. And what's crucial is that all of this is super scalable. So we can do this easily for the entire universe of self-report items, right? Which some people in the space are now also starting to do, right? And then with this space, we can do all sorts of useful things, right? We can do what people in personality psychology have done anyway, is maybe try to find groups of homogeneous items or try to find hidden dimensions within that space, then maybe explaining most of the variance. What we can also do is we can use it for assistance in generating new things, which is not something we're advocating because we've already generated so much stuff in that space, but you can use it to maybe verify whether a new item or scale that you come up with is maybe in a part of the space that is relatively unoccupied so far. And finally, what you can do is sort of this middle column, which we worked on, is use the space to bring more clarity into that space by identifying what is being called jingle and jangle fallacies, basically since the beginning of the field. So since the very beginning of the field, it's been acknowledged that we have problems of cleanly identifying the constructs that all of the different measures are measuring. So jingle fallacy would be a case where we have two measures that are assigned to the same construct or really, really similar constructs, but actually the measures are quite different. And the jangle fallacy is the opposite case where we have very, very similar measures, but the constructs that are assigned to are actually quite different. And then what we can also do, sort of try to eliminate constructs to maybe make this space more parsimonious. So crucially, we do this all with a fine-tuned model, a model that was fine-tuned to the empirical correlations that we get from human responses on self-reports. So what we did here is we pulled a number of publicly available data sets where people have been responding to large numbers of personality items. Then we can produce the empirical correlations of personality items, which is anyway in that space the most important currency in what's being used to in order to find these personality models and so on. So really the correlation between personality items is the most crucial unit in that space. And then we set up a small language model such that at the end of the model, we're producing correlation or similarities between pairs of items. And then we can compare that similarity of a pair of items from these semantic vectors to the empirical correlation that was observed for these items. And then that comparison gives us a loss that we can then backpropagate through the neural network so that we incentivize the language model to produce vectors for these items so that their cosine similarity of these vectors is identical to the empirical correlation, which works relatively well, not just in the training data, but also in generalization. And importantly, it also addresses a scaling issue because the range, the variance of cosine similarities is usually not the same as the range and variance of empirical correlations. But with that, we incentivize the model to really mimic the distribution of empirical correlations such that we can really treat the cosine similarity as an estimate of empirical correlation. The model is publicly available. You'll also, in the exercise, you get a chance to work with that model as well. In the paper, we do all sorts of different validations. Most importantly, we want to see how well we can predict then the relatedness of measures at the item and the scale level. And what you see here is one validation at the scale level from one big personality inventory that has 30 facets that together then, or a facet is sort of like a mini scale, and each of these facets are then identifying these big five, which is the most important model of personality psychology, consisting of these 5 factors: openness, conscientiousness, extraversion, agreeableness, and neuroticism. And with 30 facets, right, we have 30 by 30 correlations, empirical correlations, that we're interested in trying to estimate using the language model. On the left-hand side, you see the empirical correlations in the absolute. So we only look at this in terms of absolute correlation because all we care about is relatedness. We don't care about whether it's a positive or negative correlation, which usually is just due to sort of differences in framing, like insert a not into the item and then the correlation would be negative, but it would still be related in terms of vector in that space. And then on the two on the right show the prediction that we get out of the language model. The middle one is sort of where we cheat, right? So this is where we evaluate the model when it's trained on the data, on the empirical data, and you see it's almost a perfect recovery of the empirical correlation. But crucially, on the right, you see that when we only train on other data, we can still fairly accurately recover the patterns of empirical correlations between these measures, which is great because now, again, I mean, what we're interested in here is scalability. And what this shows us is that we can relatively accurately now identify the relationships between personality measures based on these self-reported items for basically any measures that are out there, right? Not with perfect accuracy, but in general, we have an error. I think this is a mean absolute error of about 0.07, which means that we don't know exactly what the empirical correlation of those measures will be, but we can definitely tell apart pairs of scales or measures where the correlation is low or is large. Yeah, so then what we wanted to do is maybe find these fallacies in the existing taxonomy, so the existing mapping of constructs and measures. So again, a jingle fallacy is one where we have different measures. So I do unexpected thing and never can find anything. These are not really the same tendencies of humans, but in existing taxonomies, they're often both used to measure a construct called orderliness. And that would be called a jingle fallacy. And the jingle fallacy is the other way around, where then the measure is the same or very similar and is used to measure different things like grit or conscientiousness, which are related, but again, not the same thing. So the way we went about trying to identify these measures is by, for every single pair of measures, we look at how similar are the scales. So what's the predicted correlation of these scales from the language model? So that's what you see on the right-hand side. And then also how similar are the construct labels. So that's what you see on the left-hand side. And all of the different lines are basically all of the pairs for all of these 459 different measures in IPIP. And then we can look for these cases where maybe the labels are identical or super, super similar, but the corresponding measures, the scales, are actually really, really different, and the other way around. And these would be these jingle and jangle fallacies. And we identify a bunch. We came up with some heuristics, very conservative thresholds, and that led to about 500 different fallacies that we identified. And I'll give you some examples in a moment. This could easily be way more if we would relax the criteria a little bit. Yeah. So here are some examples of jingle fallacies. So we have two different scales. On the left-hand side is orderliness from some inventory, and on the right-hand side is orderliness from another inventory. And you can really see how the orderliness, based on the items of the left-hand side orderliness scale, is really about doing crazy things. Whereas on the right-hand side is all about like cleaning up, right? Keeping things tidy, right? And to reiterate, right, this is now really a problem because researchers working with the left-hand side orderliness scale or researchers working with the right-hand side, they both write papers about orderliness, right? And then we record in our literature all sorts of different findings about orderliness, but there's no point in relating them to one another when the notion of orderliness is really so different. Here's another example, right, with orderliness in organizations, which themselves are really, really similar, but organization here is really all about tidying up, right, and orderliness here of that one is still about doing crazy things. Now, jangle fallacies, so these are cases where the scales are really similar, but the labels are very different. They often come about because people just reuse items, right? So the majority of jangle fallacies are driven by people just using the same items to measure different things, right? So here are two examples. On the left-hand side is a scale of organization. On the right-hand side is a scale of conscientiousness. And they reuse some, 7 items, right? Or they have an overlap of about 7 items, which is the majority of the organization scale and a large chunk of the conscientiousness scale. Now, organization and conscientiousness are not the same thing. So maybe we shouldn't be using exactly the same items to be identifying them. But we also have jangle fallacies where that are not based on overlapping items. So on the left-hand side, we have a scale on forcefulness, right? So whether you take the initiative or give up easily. On the right-hand side, you have a scale called happiness, where the scales have, I mean, not with all of the element, but they're in many respects are similar. So for instance, forcefulness includes an item called have a low opinion of myself, which of course is similar to I'm filled with doubts about things, right? Or seldom feel blue, right? So this is where then the items and the scales are very similar, but the similarity is not reflected in the labels that are being used to then talk about what is being measured. All right, and then the final thing, sort of towards wrapping up, is that we also then use some combination of cluster analysis and graph matching in order to come up with a new taxonomy. So what we did here is we basically produce all possible clusterings based on the semantic similarity from the language model. And then for each one, we use sort of bipartite graph matching to assign to each cluster the label that is closest within that similarity space. And importantly, we only used each label once, right? So then for the first cluster, we figure out what's the best label there, and then the label is out of the set. And then we evaluate for the next cluster, what's the closest label, and then we assign that one. The label is out of the set, and then we continue and thereby produce a taxonomy. And here you see this taxonomy displayed as sort of as 2 circles. On the outside, on the outer circle, we have the different scales, and on the inner circle, we have the different constructs being assigned. Now, the point here is not that this is now supposed to be the new taxonomy of personality psychology. Not at all, right? We're very clear in our work that this is ultimately something that can only be arrived at through a coordination process among scientists in that space. But importantly, we see this now as a proposal mechanism, and we also see it as a proof of concept that we can rearrange things and that we can also improve clarity. And crucially, that we can improve clarity with using a smaller set of constructs. So this particular taxonomy that we found here, it only uses about a quarter of all of the different construct labels. And at the same time, only commits about a half of the fallacies in that space. So it's both massively more parsimonious and more clear, right? Or less cluttered, right? Which really tells us that there's space for cleaning up. All right, now in your exercise, you get to sort of trace these steps that we took in the project, at least most of them, for one inventory, the one that I showed you the validation for. It's an inventory that has 300 items, and these 300 items identify 30 different facets. So that will be the construct column in this data set. And then these constructs are identifying these 5 different factors of this big 5 personality model. So the GitHub repository has this data set of items. It also has an empirical data set of empirical correlations. So we can evaluate how well different language models can identify or these correlations off the shelf. You can also later see how well that works with the fine-tuned model, although there, to be clear, this will be cheating because that data set was also used in the training of this data set, of this language model. And then the GitHub repository also includes the larger database of IPIP so that you can later on maybe do this for the entirety of IPIP, which is really the point of this approach, again, scalability, or just pick another inventory from IPIP to see how well things work there. And yeah, and to reiterate, really, I mean, here the question is really, I mean, on the one hand, how well can we capture empirical patterns in that space using large language models? And also then, how well can we maybe clean things up by figuring out really what is the best mapping of items to constructs, right? Or items to factors. And is the current mapping that the researchers have come up with really the best one, right? Or are there maybe things to improve? All right, and that's the end. And I'd be happy to take any questions or have you start working on the exercise. I don't know how you usually go about things. I can.
Yeah. So first, a round of applause for Dirk. And so let me like briefly contextualize this. So every year we try to do a combination of major fields of science and their contributions to computational social
Martin, I
science.
don't hear you anymore.
Oh, you can't hear me? Wait.
So, just for a moment. Now I can hear you again. Just for a moment, I wasn't able to hear you. I can hear you again.
Let me
Oh.
try to MacBook Pro microphone.
I, can you hear me? Okay.
My system. No, we're trying different ways of like putting the speakers, but maybe like I will speak here and it's going to
Yeah.
be better. So every year we try to feature as many different major fields of science and their contributions to computational social science as this like merging bridge in between most fields of science. I think this is like one of the talks that cover the psychology angle brilliantly. And for those of you who are not psychologists here, this talk is still relevant to you, even if you're not a psychologist, because we have political scientists, economics backgrounds, we have anthropologists, sociologists, and whatnot. When you are dealing with computational data, you sometimes stray into this area of one of the most popular things that even non-psychologists are doing very frequently recently, sentiment analysis. So basically, when non-psychologists try out this thing called sentiment analysis, whether a text exhibits fear, anxiety, anger, humiliation, happiness, and whatever. We tend to use certain libraries or certain like corpus, as we call it, in order to judge whether something constitutes as fear language or whatnot. So this framework is very useful for all of us. We're not necessarily psychologists, but still interested in trying to uh, sense emotions or any kind of effects from computational text, in the sense that most corpus-based approaches end up failing, especially when the computational text, Twitter data, Reddit data, YouTube comments, or whichever text you're trying to extract emotions from or sentiments from, ends up failing in different ways. And this talk was, and the instruments that you have on GitHub are actually quite a valuable gold mine in the sense that if you are working on any kind of sentiment or emotional extraction work, is super useful for you, I would say. Which actually brings us to my direct question. How much of this changes when the sample starts to become short form text of social media data versus long form of, for example, parliamentary speeches or long legal texts, for example, trying to extract, for example, conscientiousness in social media text? How different is that approach?
So, I mean, one crucial difference is that the the core datum here, of course, is both the sentence as well as the judgment that we have from people about themselves, right? So here, right, we don't have to perform any inference to figure out based right, any inference to figure out really what is their conscientiousness or extroversion, right? We basically just get it from the text and then the assignment of those items to these different dimensions. So if you wish, you can think of this as a direct measure. Of course, one can contest this exactly based on the problem that I've presented, right? Now, um, interestingly, with now these approaches that try to extract these personality dimensions, it's always a really strong inference, right? Um, One that where it's really not at all that clear how to perform this the right way, right? One approach, of course, would be a machine learning approach, where you then have from the same people the texts, right? Their Twitter posts or right, and then also have their assessment of personality based on such an inventory, and then you can try to figure it out, and that will be straightforward and probably works okay as well, but probably not very great. The other approach would be to try to go based on sort of these kernels of meaning within that space, which would be these dictionaries, right, of adjectives, for
Yeah.
instance, etc. But that's going to be really tricky, right? One is that, I mean, as I've showed you, that we're not super clear about the mapping of these sort of kernels of meaning and what they're supposed to measure. And then, of course, with social media data or parliamentary speeches, there are different pragmatic intents of use, right? Just because I use a certain adjective doesn't mean I use a certain adjective in order to refer to me, right? And my personality, right? I could use this adjective to describe someone else, right? Or a situation or whatever, right? And that obviously makes that task a lot more difficult, right? And now, again, I think probably the best approach to do this well is actually a machine learning approach. That's how I would approach it,
Mm.
to maybe get some good training data set, right? Then embed the texts and then try to decode the self-ratings of personality from these texts. And that gives me then a generalizable model, right, that it can apply to everything. But the crucial bit here will again be that, I mean, coming back to your question, that these embeddings will become a lot more muddled. These vectors, well, will become more muddled when you go from small texts
Yeah.
to really large text, because then, of course, there's this massive superposition of information, and that will make it very, very difficult to identify anything. But in general, I think, I mean, coming back to, I think the major limitation, there is always a massive inference, and really very little of what we say in everyday language is directly informing on my personality.
Yeah.
Right?
Yeah. Yeah. Wonderful. Can you come here because he won't be able to hear you? Uh, so sorry. Maybe next time we can arrange a better classroom with proper microphone work. Yep.
Hi, thank you for the talk. It was really interesting. I was curious, when you look at translating these measures into different languages, I don't know if you looked at this at all, but how much does the conceptual clustering translate into other languages, or how much messier is the what you described as the conceptual clutter once you look at the use of these measures in different languages? Does it map the same way, or are people understanding these in different ways?
Yeah, thank you. Really, originally, this project came about by asking that same question. So I saw a talk from someone whose main research topic is trying to study the structure of personality across different languages. And then I figured, wait, how can we be sure that whatever we see as differences in structure across different languages, that's really because the personality is different in these different like cultures, countries, etc., or whether this is just because of poor translation. And at the time, we weren't really be able to settle that issue. Maybe that will be better today because we have better translation tools or better multilingual embeddings than we had at the time. But so that we didn't really pursue this further. And also in this paper, we don't look at all the translation. But it really remains an interesting problem. And also with some other projects, we really had to realize, so we also do some work on like semantic alignment. We really try to see, do different people think about constructs the same way, or also do different languages think about constructs the same way? It's like translation is really this impossible thing. It's really not at all ever possible to translate something perfectly from one language to another. And it's also really, really difficult to put the finger on it, because you usually can only understand the meaning of something relative to the meaning within those languages. But if all of them are just a little bit different than in the other language, then you can't use the other language to understand the differences in that in one language. So it's really tricky. But so my honest assessment is that probably differences in translation play a role, and probably make things more messy as well. But in principle, it would be possible to have a clear taxonomic system within one language, but we don't have that because, of course, there's a super skewed distribution of work across languages. The vast majority of work in this space is going to be in English, and then probably in German and French and Spanish, and that's where it stops. And for the vast majority of languages, if at all, maybe we have one or two or three assessments where someone translated the thing well or maybe not so well. And that means that, yes, translation is probably adding to conceptual clutter.
I'm struggling to formulate this question, but I'm wondering if you can essentially use the methods that you developed to try to look at how accurately translations are capturing the concepts that they're trying to measure. And I know you kind of answered that, that yeah, it's messy, but I'm curious if you just put data in different languages.
You can't, that's the thing. You can't really do it because we don't have a perfect translator, right? So, I mean, what you could do, of course, is make a strong assumption. So you could take a multilingual language model, right, and say that there is really just one semantic space. It's like I don't know. I mean, people talk in like AI talk about this now. This sort of this idea of a Platonic representation, right? Like there's the idea that there really is just one right representation of everything, and that these multilingual language models are really able to translate anything from whatever language, or I mean, the model is trained on, to that one single Platonic space. And then, yes, then we could use a multilingual language model and evaluate a measure in English against a measure in Turkish, against a measure in German. And we would expect that they all end up in exactly the same position within that space, right? Problem is, that's not how it works, unfortunately. Different languages always have somewhat different representations, partially also because the world that is being described by different languages is not identical either, right? I mean, if you look at the entire body of text in Turkish and in English or in German, you would see that they don't talk about identical things, right? Because the world is slightly different. The weather in Istanbul, for instance, is always a little bit better than it is in Berlin, right? That means that overall the representation of weather will be slightly different or maybe largely different, right? In the Turkish language than it will be in other languages. And that means that there's just this fundamental problem of not being able to objectively assess the value of a translation. Does that make sense?
Yeah, yeah.
So, and that's the problem. So we can't really be doing this. We can't really distinguish well the part that comes from just bad meaning translation to actual differences in these different settings.
Thank you.
How much would it help to have like 15 native speakers doing like case-specific translations to build like a dedicated translation corpus for every single under-resourced language, for example? Would it solve some of the problem?
No, of course it would, and that's of course the kind of data that is also being ingested by these multilingual models. At least in the beginning. I think these days the model miraculously learns the majority of it just being exposed
Yep.
to the different languages. But especially in the beginning and probably still today, these kinds of good translations probably still form the backbone of at least an initial mapping between these languages. But again, also people that are bilingual will not be perfect translators, right? Every single translator will have a slightly different way of translating things to one another, right?
Yeah.
I mean, that's why there are connoisseurs that care about who was the translator of a book that they like, right? And then they like one translation more than the other, right? Both of these translations are valid, right? Both of these translations of a popular book were translated by expert translators, but still they're different, right?
Yeah.
And that's the problem we're dealing with, right? The problem that there cannot be a perfect translation.
Yeah, wonderful. Yes, please. Another question.
Yeah.
Thank you for the talk. One of my questions is similar to Emma's actually. I wonder, I'm so beginner at like LLM model methods, but can LLMs overcome like cultural variability of different constructs? Because, for example, some constructs can be used interchangeably in different cultures. So can we train LLM models for different cultures? For example, like we have face, dignity, and honor can be used like differently in different cultures. So can LLM models overcome this difficulty? It's like it's similar to language problem, but like in a bigger lens as a culture.
Yeah. So I think they can help, right? But there are always these issues that we just talked about, right? These issues of translation. Now, we actually at some point we tried to do this for the construct of risk. We didn't work with a multilingual model because in the multilingual model you have the problem that really these these conceptual spaces or these meaning spaces, they're not identified independently of one another, right? So in a multilingual model, then, I don't know, the Turkish representation of risk will be somewhat pulled towards the English representation of risk because the model is simultaneously trained on the data from these two different cultures, right? But what we figured is that maybe we can actually use models that were trained separately, right? A model that's just trained on English data, and a model that's just trained on Turkish data, and then a model just trained on German data, and so on. And then we can find ways to align these spaces such that we sort of have a mapping, and then we can evaluate to what extent a construct is maybe more similar or less similar. So this is this notion of semantic alignment. So what we can do is, for instance, we can then take the word risk in the English space. We can look at what are the neighbors of risk in the English space. And then we can look at the word risk in the Turkish space and see what are the neighbors there, and then ask to what extent are the neighbors overlapping or not overlapping. And yeah, and it seems to be possible to quantify the degree of semantic alignment relatively well. There's also a paper in Nature and Behavior from Thompson and Lupien and someone else where they did this on a smaller scale. The problem is then try to decode how the constructs are different, right? And that's where it's a little bit more difficult, because that's then in really exactly the distribution of the neighbors and the similarities to these words. And there we figured is a little bit more tricky. At least we found for the construct of risk, it was a little bit more tricky to do. It's just the patterns weren't super strong, and part of the reason why I think it was tricky, because really this only works when you have that mapping of spaces. So the way we achieve this is using an automatic translation engine to figure out really what's the, like, I mean, with risk, but all of the other words in the languages as well. What are like the dominant translations of these words? But that is never, again, is never perfectly identified, right? In many languages, there isn't actually a good translation of a word anyway, right? But you still have to create such a mapping in order to perform such an analysis. So long story short, yes, I think these kinds of methods can help, especially when you have them separately identified, right, or separately trained. But they're still afflicted by the translation problems in ways that later on, it's always a little bit hard to entirely trust the results of your analysis. Maybe one more thing, though, I think there's another way to go about it and not think about it in terms of just these semantic spaces, but actually think about it in terms of knowledge. And this is where I think just top of the line language models are probably good, right? So if you just have a conversation with Claude or with ChatGPT about really what are the connotations of risk in Turkish versus in German, right? It will probably be able to give you a good narrative that is probably relatively accurate. And maybe that's actually the better way of going about it. Basically just building on the fact that these models just have greater cultural knowledge ingested during their training, but also not perfectly reliable. I mean, there's all sorts of demonstrations of language models missing important cultural connotations in languages other than English because it has not yet been exposed to a comparable amount of training data in these other languages.
Yeah, thank you. And I have one more question. Like for those techniques, should be the format of the data the same? For example, for some constructs, we have both tasks and questionnaires. So can we test them like in those models, or should they be the same format? Like, should they be all tasks or all questionnaires separately?
So in your exercise, it will actually be all just questionnaires. And questionnaires, or these sort of self-report items, is really the easiest case because there is such a homogeneity in the way these measures are being framed, right? So people that construct these self-report items, they really try to make them as small as possible and still as diagnostic as possible. So it's really the perfect text corpus for these kinds of analyses. with tasks, we're actually finding now that we need slightly more sophisticated approaches to be able to identify the relatedness of task measures.
Mhm.
You also have the problem that one task can actually lead to different measures, right? Which is also something you need to resolve. So what we do here is we perform some kind of neuroscience where we evaluate what are the nodes that are important in a predictive approach of the behavior in a task. Similar to maybe some of you have seen this sort of foundation model of human cognition paper, the Centaur model that came out in Nature. So similar to that approach, but then we try to figure out really what in the neural network is important to reproduce behavior in one task versus another task, and when we compare these things to one another. But that's, yeah, it's a lot more tricky and also a lot more computational intensive. So in this exercise, it will only be self-reports.
Okay.
But allow me to make one point here also on the generality. Self-reports are everywhere, right? So many different disciplines rely on surveys and self-reports, right? So you have them in econ, you have them in medicine, you have them in all sorts of different fields, right? So finding a solution for those is already big in order to right, clean things up or understand the structure of measures and constructs across the sciences.
Yeah. And like an idea came to my mind, but it can sound so stupid, but can we conduct those studies like with small n's? I think they will, like, people get used to, of course, same items over and over again, but maybe after a longer periods, like, can we check if they answer in a similar manner for different, questionnaires? But probably they will get used to the items, probably.
Yeah. So yeah, I'm not sure, or maybe you need to say more, but in general, the idea here is that once this approach is validated, right, or maybe you have a fine-tuned model, you actually don't need the human ratings anymore, right? You can apply this now to any possible self-report item that is out there. And then it doesn't matter if you have 1,000 of them or 10 of them. In fact, I think uh, the most useful applications are really at small scales where people exactly at the point where people are thinking about creating something new. So colleagues of mine, they've now created a platform, a search platform where you basically type in the item that you care about or the new scale that maybe you want to invent. And then it's gonna, this item or scale is gonna be checked across all of these other ones within the semantic space. And then it's just returning to you the other ones that may be very similar, right? Which in the majority of cases will probably reveal that somebody has already come up with something that is like what you want to do. So maybe you don't have to do it anymore, right?
Okay, I see. Thank you. Thank you so much.
Any other questions? Yes, please. We have lots of questions. I hope you have time. Yeah.
No, of course. Yeah.
Hi. I did a little bit of my homework, and I've seen that you also have a very interesting background as a cognitive psychologist. And I have more of an opinion question. So in the field, there is a lot of debate about how do these models represent human cognition and kind of human clustering of specific kind of language and phenomena. And I was just wondering, what is your opinion about that debate? Are large language models a good representation of human cognition and human language construction? Or, yeah, kind of like, what is your opinion on that?
Yeah. So I think they are, and they're also not.
Okay.
And and there's a lot to say. First of all, I think it's really important to see these models be coming from a tradition that very much was interested in building models of human representations. So the current models are really, we can really understand as an extension of latent semantic analysis or Vertovec, etc. And especially with latent semantic analysis, the idea really was to build a model that mimics human mental representations, right? And that's still true. I think what we also, or it's still true, or it's still the case that we can treat them as such, and that they're probably the best way of measuring human representations, at least at scale. And then what we also see is that these models are really good at reproducing human behavior. I mean, again, that paper that I mentioned, this foundation model of human cognition, shows that we can actually capture a lot of human behavior with these models. And crucially, for the almost really for the first time, we have a model that can produce different kinds of behaviors at the same time and reproduce it with some level of fidelity, right? So, I mean, anyone who's working in cognitive psychology or cognitive science knows that the majority of these models that we come up, they're really tailored to one specific task, right? And then you have a model for recognition memory, but it's not a good model of long-term memory. It's also not a good model of working memory. It's not a model of decision making. It's not a good model of opinion formation, etc. Right?
So it's more that catastrophic forgetting kind of that paradigm, right? So if you retrain a model for something else, then it's completely forgetting the other task. And
no, I mean, usually what we have in cognitive psychology and cognitive science is these small models. People really focus on understanding, right? And then they come up with 2, 3, 4 parameter models that are tailored to a specific experimental paradigm.
yeah.
And now really for the first time, we have a model that can work, that reproduces behavior across many, many different tasks. And yet it's not a perfect representation. And also there are fundamental aspects about these models that are not human-like, right? One example is that they have much better working memory, right? I mean, Claude now has a context size of 1 million tokens, right? Humans struggle keeping a dozen tokens at the same time in their mind, at least in terms of really, in terms of fully accurately reproducing all of these tokens, right? And that means that they are probably not perfectly implementing the functions that the human mind is implementing. And still, I would claim they are probably the best model of the human mind that we currently have available, and we need to take them serious. And I am often getting a little bit angry when people now, for instance, look at the way these models are trained, right? There are these things of, oh, it's just a next token predictor, and therefore the model can't be anything like humans, right? Or that the people now look at some differences between LLMs and humans and say, oh, look, it's nothing like humans, right? But the same thing can be said about every single model that cognitive psychology or cognitive science has come up with, right? We only have bad models available, and probably this one currently is the best model that we have. And I think people are slowly warming up to it, and I think it may be ushering in a new period of sort of more behaviorist thinking about human cognition. But let's see.
Okay, thank you. Yeah, very interesting to hear your opinion about the debates. Thanks.
Thank you.
Any other questions about psychological constructs, language constructs of psychological states? Yes.
Thank you very much for the interesting work. I just want to ask a question about the methodology in the background. So I saw that in your article, you're using basically 4 different methods for analyzing similarity. So you have the cosine similarity, Cronbach's alpha, structure fidelity, scalable label alignment. So in the exercise, I have seen that we have the output for cosine similarity and the Cronbach's alpha. And you also have supplementary material for your article. So, but I couldn't find the structure fidelity and scale label alignment method. So is it possible that you guide me where to find those things? And also, I want to ask the graph that you constructed for jingle jangle, which method you were sticking to when you are doing that?
Yeah, so I think it's important to understand that Crumbus alpha, structural fidelity, and the other ones, these are just different evaluations of um, the ability of the language model to capture human empirical data, right? So these are all 4 different ways of looking really at the same question. And the question is really, to what extent can the large language model capture, or the cosines that we get from the large language model, to what extent do they capture the empirical correlations? Because then the empirical correlations are what is driving Combos alpha, right? So Combos alpha is just a summary of the empirical correlations of items. And also the structure of inventories has been derived from empirical correlations of items, right? So the core comparison, at least on the measure side, is really just the cosine of the semantic vectors and then the empirical correlations. And that's what you'll do in the exercise as well.
Okay.
Now, in terms of label fidelity, you'll actually do something like that in the exercise as well. You're just not quantifying it in that z-score that I have in the paper. You actually do a little bit more detailed work and look at really what are the kinds of errors or misassignments that the language model may make, or where may have the designers of that inventory assigned the wrong labels. So you'll specifically look at this in terms of a confusion matrix that gives you all of the information and the information that would lead to the z-score that we have in that paper as well.
So the benchmark method is cosine similarity, and the other 3 methods are for robustness check?
No, they're not. No. It's just the other 3 measures are just a consequence, right?
Mm-hmm.
Of the mapping between cosine similarity and empirical correlation,
Okay.
right? They're just sort of different aspects that personality psychologists care about, right?
Mm-hmm.
But the measure of performance is the correlation between cosine and empirical correlation.
Mm-hmm.
That's really really almost the only comparison that matters, because from that all of these other demonstrations would follow naturally.
Okay, thank you very much.
Yeah.
Any other questions? No. Well, thank you so much, Dirk. It was a pleasure. Can you just remind everyone again what their data challenge is?
Yes. So in the GitHub repository, you know what? Let me show you real quick. Let me walk you through this for a moment. Let me pull this up. So this is the GitHub repo. And right, probably at first it would make sense to just read through the README. And then you can go to either exercise IPython notebook or exercise RMD. I had Claude yesterday create an R version of so this is an exercise that I've taken from an LLM course that I've been giving over the last few years. And I've asked Claude to create a version in R. I wasn't sure whether you work more in R or in Python. So you can do either one here.
It's a mixed group. They use both.
Good. So then pick whatever you're more familiar with, right? Either the IPython notebook or the R Markdown file. And then you can walk through it. Maybe the notebook loads, right? Yeah, and it's a relatively elaborate notebook, right, with a bunch of text. And really everything is already there. You can, especially if you're familiar with Python, right, you can quickly go through this and then maybe move more quickly to the final part where you are expected or where you're asked then to maybe run through the same pipeline with a different data set, right? Or, I mean, or you spend all of your time here, maybe mess around with the code, whatever, right? Yeah, so working through that is your challenge. And then, yeah, I guess here at the end, you'll be asked then to work with the full IPEP data set where that's a good point. In principle, you could also try to figure out whether the assessment or the estimate of alpha is mapping the empirical data. You can investigate the item keying. So this is whether an item is framed positively or negatively with respect to the construct, whatever. But the vanilla challenge would be then to either use the entire IPIP, which has data from all sorts of different inventories, or just pick a different inventory and carry out the same analysis that the existing code is carrying out for the NEO inventory.
Okay.
Okay.
So, is anything unclear? And everything is perfectly clear. We have thumbs up. Okay, they understood. Thank you so much, Dirk, and I hope to see you here when you're here as well. I have tons of questions to ask you as well when you're here. Thank you so much. Let's give a round of applause, please.
Hey, thank you for having me. I'm looking forward to seeing you in person in a couple of weeks.
Yes, take care. Bye-bye.
Bye-bye.